Good evening everyone. On behalf of CMET Pune, I welcome to all of you here for today's lecture. Today we have speaker Dr. Nagesh Khupse, research scientist from CMET Pune. Dr. Khupse completed his MSc from Savitribai Phule Pune University Pune and PhD from CSIR National Chemical Laboratory Pune. He worked as a postdoctoral fellow at National from Hava University Taiwan. His area of research are lithium ion battery, solid ion battery, ionic kinetic investigation of chemical processes, etc. His scientific contribution has been recognized and published in highly reputed international journals, more than 13 publications. He is also a recipient of highly prestigious award and honors on his name, elected young associate 2018 Maharashtra Academy of Sciences, DST Young Scientist, Science and Engineering Board, New Delhi, India. He is also a member of many scientific bodies in India and abroad. I welcome here to Dr. Khupse to deliver his talk. Sir, please.
And visiting. Okay, thank you so much. Good evening, everyone. Thank you, Saidi, for such a nice introduction. Uh, this is Dr. Nagesh Khupse from CMET Pune. And in the next few minutes, I will talk on how it is important to work on maintaining the sustainability in a recent time. As we know that in almost like a research community, each and every is contributing towards these programs. Now, how green chemistry is play a very significant role in maintaining the research, sustainable development. So, as part of this, now in the next few minutes, I will just introduce a few about sustainable development, followed by what CMET is contributing towards this program. So sustainable development is nothing but an organizing principle for meeting human development goals to provide natural resources and ecosystem services on which economy and society depends. In other words, we can call it as a development that meets needs of the present without compromising the ability of future generation to meet their own needs. So it is very important to balance the environment, social and economics. As we know that in every part of this world, we are facing serious issue about in almost in everything about population, about pollution, water, energy crisis. So we have to balance these things, even though we have, in order to also we have to provide all the resources each and every. So Union has set few goals to complete by 2030 to yes. UN has set almost 17 goals to maintain the sustainable development. As we have before this, that there should not be any poverty, zero hunger, good health and well-being, quality education, gender equality, clean and water sanitation, affordable and clean energy sources, then decent work and economic growth for everyone, industrialization and infrastructure facility, reduce inequalities to maintain the sustainable, responsible consumption and production, sustainable cities and communities. Also, we have to work on some climate action, life below water, because that is very important part of our in ecology, in maintaining the ecology balance. Life on land as well, peace, justice, and strong institutions, and participating for our goals. These are very important goals we have already said, and we have to work. Everyone, each and everyone has to work on this and has to become responsible, contributing these goals in the next few generations. Now, these are the serious issues recently each and everyone in this world are facing about the global warming, natural crisis, that about fuel crises, acid rains due to the air pollution, what waste disposal, that waste disposal, and then air pollution, water pollution, ozone depletion, which is the effect of all the pollutions recently we are facing, and very serious issue about the destruction of forest, which we can work very seriously in this point. Now, what is exactly the objectives of the sustainability? The sustainability is nothing but to understand the importance of green chemistry for sustainability and to design and interpret the greener route to the traditional chemical reaction. So these are the very important two objectives as a green chemistry play in maintaining the sustainability. So how do these develop? The design and application of chemical product and processes that reduce or eliminate the generation of hazardous substances. The concept of green chemistry developed as a natural evolution of the pollution prevention initiatives and improve the environmental performance. And also very important to include this green chemistry part in the learning programs as a new educational path for sustainable development. If you consider three objective or three important point, maybe green chemistry maybe play a very significant role in maintaining the system. But green chemistry work on major 12 principles, as everybody knows. And these principles are very important in maintaining the ecology as well as for sustainable development. The prevention, first one will be the preventing. It is better always to prevent the waste than to treat or clean the waste after it has been created. As we know that to stop the waste, actually we create the waste that if you stop there itself, maybe it will be very important. Atom economy, the synthetic method for a design for synthetic method we use for synthesizing any material. So, sorry for the interruption. Just there's some technical issue. Sorry for the interpretation. No, just so atom economy. The method should be designed that maximum incorporation of the input material should be consumed to convert into the final product. Less hazardous and chemical synthesis. The method should be designed in such a way that there should not be any toxic issue to the human health or the environment. Designing of safer chemicals. The product or the material we are synthesizing should be safer and should not have any harm issue with the environment as well as the human being. Very important, that is solvent or auxiliaries. The use of different solvents for a different procedures should be made unnecessarily whenever possible and innocuous when used. As we know that compared to the reactant material, we are using more solvent and we leave it into the environment, which will cause a very serious issue to the environment. And this is the only the fact. This is the only the principle, one of the principle we will work on and maybe resolve the maximum part of issues what we are facing in at the same time. Design on energy efficiency. The energy requirement should be recognized for the environmental and economic impact should be minimized because the parameter we are providing for this like pressure and temperature should be very well maintained. Should not use maximum things for carrying out the reaction in order to balance the energy efficiency. Use of renewable feedback. As we know that sometimes we know that those are the raw materials or natural resources should be used instead of some kind of plastic or some other things. May be useful. Reduce derivatives because unnecessary. If you carry out any reaction, so unnecessary derivatization or something maybe should be reduced unnecessarily because such substance may not be used for your final product. So 100% conversion, such kind of things should be there. Catalysis, like in Marathi we call this very important in the things. That catalysis reagents are very important. It should be in a minimum quantity and should be used for the maximum conversion of the product. Design for the degradation. The product we use for any chemical processes or after is synthesized or after it's used should be like a degrade. It should not be lived in the environment or should not be issued to causes some issue with the environment. Most important, the real-time analysis for the pollution prevention. Because during the any processes, it is very important for you to monitor that processes. Because sometimes some side reaction may cause some kind of toxic substance come out of this some chemical processes, and you have to monitor with time as well in order to this. And inherently safer chemistry for accident prevention. During any reaction, you should not use any toxic, explosive, or some accident causing reagent for carrying out any chemical process. These are the 12 principles where the green chemistry work on and should follow each and every researcher. As I know that in Marathi that from तुम्ही सगळे BSc आणि MSc चे मुलं आहात आणि भविष्यामध्ये बऱ्याच ठिकाणी तुम्हाला आता रिसर्च करिअर किंवा तुमच्या ज्या काही रिस्पेक्टिव्ह एरियामध्ये तुम्हाला काम करायचं असेल मी तर तुम्हाला रिक्वेस्ट करेल दिस इज युअर रिस्पॉन्सिबिलिटी आवर न्यू जनरेशन रिस्पॉन्सिबिलिटी टू मेंटेन the ecology, to balance the ecology and to take care of the environment for sustainable development. You should be more careful about following such rules. So you should work on such area where our environment should be eco-friendly, remain eco-friendly, and should maintain our conditions. Now, as part of cement, that cement playing very significant role in contributing towards the sustainable development. As I told that one of the important principles of green chemistry, that is the use of solvents. And in this regards, cement is playing very significant. That we are using some kind of eco-friendly solvent systems, and in a different area of research. And we are also in a I'll in the next few slides or in the next few minutes, just I will explain one of the very potentially important material which will be used for a number of applications, which has highly potential properties, interesting properties, and that's why it has many applications in different fields. And in our issue, we are doing the same thing. Now, what is this material? So, ionic liquids very important material. You can see the structures. Here are the few examples of ionic liquids. It is a room temperature molten salt. It is composed of entire cations, and it consists of organic cation and inorganic cation. Here are the few examples. If you see here, that imidazole based pyridinium, some ammonium, phosphonium based cations, with few are bromide, some halide based hexachlorophosphate, and ATF2 based anions as well. And these are the very important. These are also commonly known as molten salt, room temperature ionic liquids, liquid organic salts also. It has many applications in different scenes. Now, before going, just I will give the historical background about these ionic liquids. The first ionic liquid was synthesized in 1914 by P. Wharton, and it has been used for chemical processes, electrochemical processes. But some issues where some kind of explosive nature of such ionic liquids has stopped working on such ionic liquid. Further, after almost 25 years, in 1948, that Hurley and Wire group has used some chloroaluminate based ionic liquids. But these ionic liquids are highly moisture sensitive, so cannot be used for any number. You have to be very cautious. You have to be very careful when using these ionic liquids. Further, in 1963, some metal-based ionic liquids system came in picture, and then little bit work has been started on such systems. And slowly, in like a very limited applications has been came, and it was showing some kind of very interesting result. But very major breakthrough happened in 1992, where air and water stable ionic liquid came by J.S. Wilkes, and has a real research area of work on this area. Research work on this area has been started in number of applications. Now, why these ionic liquids are important? Because now anything like कुठली वस्तू एखादी काय interesting होती, because it has some kind of very novel, interesting properties. So now, how these materials are important in green chemistry, that is very important aspect of this topic. Now, as we know that as a solvent system, UG, it should have it should be very stable, thermally as well as electrochemically, if you want to carry out any electrochemical reaction. Thermally very stable because it should not be let into the environment because of the environmental pollution. Because in most of the industries we are using huge solvent systems, and in that case we should have some kind of stable. It should be thermally stable. It should not evaporate easily. So vapor pressure should be minimum so that we can use it at a wide temperature range. So they have negligible vapor pressure, non-flammable, so very safe to use to handle these highly thermal, chemical, and electrochemical stability. So you can use at high temperature reactions. Electrochemical stability means wide electrochemical. So you can carry out number of rate of reaction in these solvent systems. Liquid wide temperature range. Dissolution of many organic inorganic compounds. That is very important or serious problem in organic chemistry. That most of the times these organic compounds are not dissolved in common solvents, but ionic liquids may be like useful in such organic processes. Then variable visibility with water and organic solvent. Because sometimes ionic liquids have few limitations of some properties I'll explain. And in that case, we have to use some binary system as well. So you should have visibility or solubility with other organic solvent as well as water system as well. And very interesting and important thing about recyclability. Because it is known that ionic liquid are a little bit costlier, but when you recycle, that is very important. And these ionic liquids can be recycled and further used without losing its activity or its original properties. And all these properties you can deem by different compositions. Means, as we know that ionic liquids have cation as well as anion. So you can tune these properties by taking different cation and anion. So you can go for you can design number of ionic liquid systems. Now these are the few examples. These are the applications where the ionic liquids can be used. In organic synthesis, already I explained the organic synthesis, catalysis, and as a solid medium as well. Because in solid medium, in a high temperature organic reaction, you can carry as catalysis systems. Because we can incorporate some metal-based systems and it can be used as a catalysis for some chemical processes. Engineering, separation, extraction. These are highly applied processes where ionic liquids are playing very important role. Because in extraction also you can go for hydrophobic ionic liquids. In that case, and most of the ionic liquids has some kind of extraction ability to form a complex with some kind of metal systems. So you can use some in such engineering process as well. Electrochemical fuel cell and lithium battery. These are very recent, very important, highly hot topics. Because in lithium and battery, we are seriously facing the issues about the conventional electrolyte of leakage issue or some flammable issue or some accident that recently has come in very recent. Some few incidents has been noticed in the recent time, where ionic liquid are replacing this conventional electrolyte and showing some very important results in a recent time in this lithium battery. In biotechnology, as we know, these ionic liquids are non-toxic and it can be used in biotechnology or biological systems as well. And also in some additives in lubricants also, because they are stable. Now, before doing this, I will explain one by one how the ionic liquids are important. Very important thing is that when you use these ionic liquids, you should know its solution dynamics. Here I have few recent results that we have considered different classes of ionic liquid and also few anions as well. So how these combinations make change the solution dynamics of ionic liquids, and through this we have studied in detail that we have changed the anion, we have changed the cation, we have changed even the alkyl chain length as well. So this is the ET parameter. This is electronic transition energy we have determined from the Richter style using these ionic liquid systems. And what we have noticed that those ionic, now this is pyridinium, pyrodinium, phosphonium, and these are tetrafluoroborate anions. So what we have noticed that those ionic liquids have longer alkyl chain length. Now if you replace with R with some kind of hexyl octyl groups, have less solution ability compared to the lower alkyl chain length. And even if you change the anion and cation as well, also change their solution dynamics. Means our aim is to aim is to tell such system you can design number of systems as per your applications. Because not necessarily that you should use for particular. Now whenever you feel like okay, I need liquid of such property, you can design that. Because you should go with the very basic physicochemical properties of data. Then only you can select the ionic liquid of your own use. So that is very important aspect of selecting these ionic liquids. Now ET parameter, if you see from this parameter, some BF core base, if you see, they are very sensitive towards temperature And while the BFS are, they are very insensitive towards temperature. Means only I am changing the anions, but showing a lot of change, significant change in their solution dynamics. While in case of phosphine base, it is showing exactly contrasting behavior, where we have observed the increasing this electron range, their polarity is increasing with temperature. This is exactly the very different behavior compared to the other conventional other ionic liquid systems. No max change. So these are the now again earlier were the protein ionic liquids. Now there are some issues related to slide one. I'll go with this way. Okay. Now earlier there were some protein ionic liquids. Now I'll go through the protein ionic liquids, where I did not use any alkyl chain. I have substituted with the only proteins, and these are highly acidic in nature as well. Now if you see compare earlier part with this one, that protein ionic liquids have very strong solution ability, where we have not noticed any temperature sensitivity towards ET parameter, because almost it's similar in change. No, it remains almost unchanged with temperature. However, we are also substituted with different alkyl chain length also, where a little bit variation we have noticed with temperature. So it indicates that this protein ionic liquids a little bit have less solution ability compared to protein ionic liquids. Now, how these ionic liquids are is like a changes in binary systems as well. Now, for this, we have studied some binary, we have taken some binary systems and studied the preferential solution. Now, कधी कधी आपल्याला एखाद्या बायनरी सिस्टम मध्ये लाईक टू सिस्टम्स आहेत आणि त्या केस मध्ये कुठली सिस्टम मोर सॉल्व्हेटिंग आहे ते कुठली कॉम्पीट करते सॉल्युशन डायनामिक्स मध्ये त्यासाठी आपल्याला प्रिसिजन सॉल्युशन एक व्हेरी डिफरंट व्हेरी इंटरेस्टिंग प्रॉब्लेम आहे आणि याच्यामध्ये लाईक व्हॉट एक्झॅक्टली वी स्टडी द बल्क कॉन्सन्ट्रेशन इज डिफरंट फ्रॉम द सॉल्युशन around that solute we are using for this study, we notice that the solution sphere around the solute is different compared to the bulk one. And which is also important to know which solvent is more rich around the solute in compared to other. So that is one we need to notice. So for this we have studied some different ionic liquid based systems, like some pyridium based ionic liquids we have chosen, and some solvent system we have chosen. Solvent system we have chosen with wide difference in their dielectric constants. So water is almost higher, almost close to 78, methanol is close to 32, and dichloramine is close to 10. Means how these properties of solvents play very significant role in precision solution dynamics. Now what we have noticed, now again we have determined the ET parameter for this one, and on addition of water, small amount of water, very drastic decrease, very drastic down in their ET values, and this ET value comes into the region of ionic liquids. Means like even you add a small amount of ionic liquid, immediately that solution sphere around the solute is become more rich with ionic liquids compared to the water, even though water is more polar than ionic liquids. While in the case of DCM is highly very low polar. In that case, it is obvious because ionic liquid play very, it's like the solutions pair become more and more rich with ionic liquid DCM system with ionic liquid compared to ionic liquid water. But very interesting behavior we have noticed in the case of ionic liquid methanol region, methanol mixture, where the synergistic effect of this binary mixture is observed, where the mixture shows higher polarity compared to the either of the pure solvents, like even ionic liquid with ionic liquid as with methanol as well as ionic liquid as well. So this interesting that synergistic effect we have noticed. Such effect may be noticed when both the solvent system have some kind of complex formation ability due to, for example, somebody has hydrogen donor ability, someone has hydrogen acceptor ability. If both the values are or both the points are same, they form the complex, and in that case the mixture shows higher solution dynamics compared to the pure one. So these things, and these are the two models we have used for these are the theoretical models where it uses the exact parameters and it tells about the exact what this is that solute that what around the solute which solute is more rich compared to the other. Now again one more important thing that as we know that ionic liquids are ionic in nature, so it is very important to know their ionicities. Now what ionicity is like nothing but two, it's nothing but the availability of free ions in electrolyte solution. Means when you add it into the solvent, now this there is the two ions, cation and anions, and how these ions will be the free for the conduction of or giving the ionic conductivity. So it is nothing but the ionicity. This is a Walden plot for determining the ionicity. Now this is the ideal line of this is ideal line. If the our ionicity of our material is around this line, means it is quite important for particular applications. And if it is beyond, it's super ionic, and it is below lower, it's like non-ionic nature. Now we have chosen two ionic liquid systems, like protic as well as aprotic ionic liquid, as we have studied for the solid atomic study as well. Now, if you see here from here, like aprotic ionic liquids are very close with the ideal lines, while the protic ionic liquids are far away from this. Means like in case of aprotic ionic liquids, they can be very strongly or potentially important for any chemical process, especially if we are determining ionicity. It's very important in electrochemical process. While the aprotic ionic liquids do not be that much important, considering its ionicity value. So that is only the difference. And again, we have changed some structural variation here that are like butyl, hexyl, octyl, and also in protic ionic liquid also we have various some structures as well. Now, very important because even in our institute also we are working on some electrochemical studies for testing the lithium-ion batteries, and we are already have program on using these liquids for lithium-ion battery as well. Now, and these are found to be very interesting. Now, what is criteria exactly for ionic liquid to be used in some electrochemical processes? It's very important to have this wide electrochemical window, and second is its ionic conductivity. Now, we have noticed that some pyridinium-based ionic liquid with TFSI or NTF2 anion shows almost electrochemical window as high as of around 6 volt, while MMBF4 we are almost noticed 4 volt, which are far higher compared to the conventional. And we have I request audience, please mute yourself. Now, for this purpose, we have studied electrochemical oxidation anthracene, as we know that the ionic liquids are known to be micro heterogeneous nature because it has cationic part, which are, and it has also alkyl chain part, which is non-polar, and cationic part is a polar. So polar and non-polar means they will not be in homogeneous state, always in a micro heterogeneous state. Micro heterogeneous state means like a cation will be cation will be the close proximity, while the alkyl chain remain away from the this cationic part. So this how this micro heterogeneous nature play a role or this structural role in a diffusion of this anthracene or any electrochemical. So for this only we have studied this anthracene electrochemical oxidation of anthracene, and we have to check the whether it follows the Slope-Einstein equation of diffusion of this anthracene versus the inversely related to the viscosity of the system. Now, for this is a cyclic voltammogram for the oxidation of anthracene in butyl iridium pyridinium liquids, and it has noticed that the peak current increases with increasing the scanning rate. Now, this is the IP current. This peak current versus again the scan rate, and it has been noticed that it's a straight line, and from that we have determined the diffusion coefficient. Now, here is if you see from the table, like now any diffusion process, if you want to move this, like there should be a less retarding or opposing force. Now, what we have noticed in the case of pyridinium based, I'll show here. Now, if you see here, pyridinium we don't have pi system, while in case of iridium and iridium we have pi systems. So, what we have noticed that when you move from butyl to hexyl to octyl, we have noticed that the viscosity also increases, and also the diffusion coefficient decreases. So it is obvious because it is inversely related and almost follows the Stokes energy. While in case of pyridinium and imidazole based systems, the diffusion coefficient is not in a order way, while the viscosity also increases from like butyl to octyl. Similarly, in case of imidazole also, we have noticed the viscosity increases from butyl to octyl, but we have not noticed as per the we have noticed the diffusion changes as per the viscosity or with alkyl chain. And these things indicate that some structural aspect of ionic liquids are also playing very important role in any diffusion process. So what we have noticed that those ionic liquids have pi systems and also anthracene have pi systems. So maybe some existence of pi-pi interaction, maybe that maybe retard the diffusion process and doesn't. In order to, in addition to research, also this pi-pi stacking may be the playing important role in the diffusion of this diffusion process. So we have noticed what this in case of pyridine as well as the pyridinium based systems, where it doesn't follow the Stokes-Einstein relation. That is the viscosity versus diffusion doesn't follow. It remains almost in the constant. While in case of pyridine system, we have noticed that it follows the Stokes-Einstein relation. Now, this is about electrochemical. Now, I am taking one by system. How each and every part of this research area. Means those students are from organic background, those from physics, those from physical chemistry, inorganic, almost like everyone can see that how these animals are playing maybe important in all areas of research. Now, there are different properties of ionic liquid, like already we electrochemical, their solution ability, their polarity, and now we are testing the viscosity of the ionic liquids. Now, as we know that in a highly viscous system, any reaction process is very slow because you have to cross that barrier, that viscous barrier, the diffusion barrier, then only reaction takes place. Now, in case of intramolecular reaction, now here two molecule has not come. Only in intramolecular reaction also viscosity is playing, but in the opposite way. Now, what we have noticed, we have carried out this intramolecular reaction of Diels-Sanders reaction. This is Diels-Sanders reaction. This is a diene, and this is dienophile. Now, it is simply diene-dienophile addition reaction. What we have carried out this into the low viscous as well as high viscous ionic liquid system. So, what we have noticed that in a low viscous, the reaction is slow, while in a high viscous reaction is fast. Very opposite behavior we have noticed, and this has been observed that now again we have calculated some theoretical calculation that in case of the intramolecular reaction, where the rotational diffusion is very important. And rotational diffusion means that rotational microviscosity is playing significant role. And the reaction occurs only the high viscous medium only favors to occur the reaction. While in case of lower viscous systems, where the microviscosity not playing role, and hence the reaction is higher. The reaction rate is lower in low viscous systems. So these two. But in case of bimolecular reactions, what we have noticed is a translation diffusion. Means two reactors, if you want to close together to occur the reaction, this reaction has to cross the highly viscous barrier to occur the reaction, to happen the reaction. And in that case, the highly viscous system shows the slow rate, while the low viscous system shows the high rate. So in that case, the translation microviscosity is playing significant role compared to the rotational. Now, as we know that one of the strongest limitation of use of ionic liquids for any applications. So what we have studied these ionic liquids in binary systems with some molecular solvents. Now here also we have measured the water, which is also eco-friendly and can be it will not have any issues with the environment. So we have measured this water as one of the ionic liquid as a molecular solvent for these binary systems. So what we have noticed. In case of the ionic liquid, we have carried out the same Diels-Sanders reactions in a binary systems, and we have determined the rate constants. Now, in a very small quantity of ionic liquids, we have noticed almost 20% of the volume by volume, like ionic liquid 20% in water. Almost the ionic liquid is driven by the ionic liquids only. Means like it doesn't show the viscosity, because viscosity almost, if you see now, I will show how it changes with viscosity. Now, drastic change in the rate constant with the addition of ionic liquids. And once the ionic liquid region start with increasing the ionic liquid region, it further level off. Now, if you see here, in case of methanol region, also we have noticed because it decreases, further remain in a constant, and further it go down to ionic liquids. While in DCM, in that case, we have noticed a little bit the viscosity effect. Now, in order to see how the viscosity is playing role in directing the kinetics of the reaction. So we have just plotted the ln K1 consists like the rate constant versus ln viscosity. If it would have shown the straight line, means that the viscosity is playing role. It doesn't show the viscosity. It doesn't show the straight line. Means that in addition to viscosity, some additional factors are also directing the kinetics of the organisms. While in methanol system also, as we already know that this mixture part is becoming very different complex systems. It shows the synergetic in the polarity parameter. Here also we have noticed in the case of kinetics also, where the rate constant we have noticed in the mixture is little bit differently compared to the almost same with the polarity system. While in the case of DCM system, almost shows rate. Means in a low polar systems, the rate constant or kinetics are almost exhibit or following the viscosity part. Now, what is enthalpy entropy compensation? Because already I told like all binary systems we have noticed little bit not exactly following the viscosity role in directing the kinetics relation. So what we have studied the temperature dependent kinetics of the study, and what we have noticed as we know that when the rate constant increases means this activation energy or enthalpy activation should be go down. But in our case, up to almost 0.1 mole fraction, we have noticed that even though the viscosity the rate constant increases, but the enthalpy also almost showing the same here. No, viscosity, sorry, rate constant increases and enthalpy of activation almost decreases. Means this is almost like a means enthalpy is not playing role. In that case, the entropy is playing role. Means like in that small region, entropy also directing or something playing some role. So that's why if enthalpy is not playing role, entropy means like some structural organization or some what against the molecular dynamics at molecular level may be directing the kinetics of the reaction. So in that case, entropy is compensating the enthalpy effect. So that was an interesting behavior we noticed, and that we also reflect in the binary systems also. Now, further we have moved towards the material science as well, like for synthesis of nanomaterials and how this animal can be play as a stabilizing role or some kind of as a capping as well as some kind of we can say like how it is stable up to what limit is stable. Now we came one paper recently across in the use of some lower alkyl chain length and liquids for synthesizing gold nanoparticles. And we noticed that within 7 days, that ionic liquids are becoming like it shows some kind of agglomeration. It's like ionic liquid is that beaming based ionic liquids, and doesn't stabilize up to that limit as per we have observed in other conventional systems. But what we have observed, one small impurity left while synthesizing things, and we noticed that even after a few months also it is showing like very stable. So what then further we have extended study and we have used different alkyl chain length based ionic liquids. So different alkyl chain lengths, which now what we have changed from lower alkyl chain to higher alkyl chain length, which exists some ionic liquid, some liquid crystalline region. Now if you see here crystal packing diagram like where this longer alkyl chain length remain away from the cationic part, and some order structure we have noticed, which exhibits also liquid crystalline behavior, and we use these ionic liquids for the synthesis of gold nanoparticles. And what we have noticed, these ionic liquids are almost showing almost stability up to even more than 1 month also. And this is the NMR, this is the neat NMR, and after incorporation of gold nanoparticles. So what we have noticed, some gold nanoparticles, some peak related to alkyl chain length, we did not observe any change. While those are proton at the ring, we have noticed little bit upfield. This like this gold nanoparticles only interacting with the ring part, not the alkyl chain length. So this is like if you understand, this is gold nanoparticle surface, and this is alkyl what imidazole ring attached with the surface of gold nanoparticles, and this alkyl chain remain away from the surface. So this is only attached, and only again one more part, like in earlier system those are thiol based systems where it is covalently bonded. Here in our case, ionic liquid is ionically bonded, and this is very important because it will use some labile nature and may be important in directing number of some chemical processes or sensitive towards any some optical properties of some solvent system. So what we have studied is how these systems are sensitive towards the properties of the alcohols, or here alcohols are even in a different molecular solvents as well. Now this is the SPR absorb this UV spectra or SPR for different solvents with alcohol systems, and this SPR we have just plotted against the direct constant of the methanol. It shows almost it follows it's like it changes with the direct medium of the alcohols. It's like in methanol which is highly polar, having direct constant almost 32.6, which shows almost red sick, while those are up to decanol almost it has direct constant up to 8. It is showing almost in the what I can say which is a standard peak of gold nanoparticle, which is the characteristic property, almost close to 520 ratio. So this variation we have noticed, and it varies with the delta constant. Further, we have used this gold nanoparticle ionic liquids for the phase transfer, because number of reaction you might have noticed that it happens in a biphasic system. And in that case, if you design some ionic liquids, any gold nanoparticle, it should be soluble in both ionic liquid as well as in organic as well as aqueous region as well. So we can tune these ionic liquids accordingly as per their. So what we have noticed that now we have kept this gold nanoparticle with bromide base. Here bromide as anion we use, and what now we synthesize in water. Now we have to transfer into this one in a non-aqueous or organic layer. So in that case, we have to make it to hydrophobic. So we know that NTO2 base, those if you ionic synthesize those with NTO2 base, immediately it change VR with the NTO2 and become hydrophobic, and directly it transfer to non-aqueous or organic, and without changing its original property. Now we see here this is a TM before transferring and this is after transferring. And notice that there is any change in the size or any agglomeration we have noticed even after transfer also. And there is very simple method we have published in the lecture last 1 year before it. And very simple method. And even like their sensitivity also we have noticed it doesn't change. Now this is after transfer, after phase transfer also we have almost in all the organic solvent we have measure is EV and determine this SVR band almost all the same which we have noticed in the all solvents, and it varies with the refractive index. So this is very interesting behavior we have. It's like ionic liquid in the case of ionic liquid, that even if you change the structures also it will not affect the other properties, but you can tune these properties by changing the composition of the ionic liquids. Now what further we have used this gold this ionic liquid for the synthesis of palladium nanoparticles. In that case, we have used a different composition or different percentage of ionic liquids. Now, if you see here, palladium, this is a simple reaction, palladium chloride with C12, that imidazole attached with the C12 based alkyl chain, and these are showing highly stable as well, and used for further study. But before that, we have studied some very interesting work, very interesting, some high resolution NMR studies for seeing how it is interacting with the palladium surface. Now, what we have here. Now we have used high-resolution HRMS proton NMR spectrum, which is very strong tool to study the interaction of ionic liquid with the palladium nanoparticles. Now what we are doing, this is simple like a NMR tube, you have to fix and you have to spin this with different spinning rate. It's like just only you have to spin like our roller coaster, that horizontal roller coaster. So what happened, like when you move it, that outer means like here we have a synthesized palladium nanoparticle capped with the bi-layer systems. Like this is the first one layer and this is the second one layer. And when you use this for this if you study that different spinning rate, now if you here just only for pictorial representation at high spinning rate, this outer layer coming out, and even like if you go further, then inner layer also coming out of this. This like I said, due to the centrifugal force that the bi-layer systems can be differentiated like inner and outer layer, and that will also we have noticed from the NMR study. Now if you see at close to 9 that peak. Like it is that peak is almost before spinning, and when you spin at higher and higher, like even at 3 kilohertz, then 9 and followed by 12 also, like the two peaks are separating. Means that outer layer is getting separated from the inner layer. That you can compare it from NMRs also. So these things like that, these things indicate that your palladium is not very strongly interact with ionic liquids, and it can be interact with your product as a catalyst for any organic transportation as well. This study also we have carried out for replacement. And finally, what we have used now, because as we know that from the NMR study as well as the ionic interaction, may leads to the more level nature of your nanoparticle and how it is useful for the any organic reaction or any. So for this. Just only we have used this palladium nanoparticle capped with ionic liquid for Suzuki coupling reactions. And what we have noticed, in a 10 mole percent of the palladium catalyst, in a very short time, in almost 10 minutes, it's going conversion with close to 99%. And also even after 5 moles, also close to 94. And these reactions we have carried at room temperature. Those reported system, earlier system, those all temperature they have to use maximum amount of catalyst as well as very lesser yield, and also they have carried at high temperature. But in this case, so these ionic liquids, why this is important? Because in all area, almost like still we have many things to show. But maybe in the next couple of in the next 2 lectures, maybe we go for exploring other additional aspect of the research of ionic liquid can be explored in a different area of research. But this is what exactly we are having. And in our cement also we are contributing this ionic liquids in a different area, in lithium ion battery or some additional polymeric systems we have designed as in solid electrolytes as well. And further we are also extending this one for next level also. Is this, I'll just conclude, and in conclusion, I'll just few things I'll say. There need to be more database on physical chemical properties considering their applications. Comprehensive approach towards the ionic liquid application, because we need to be very selective towards the ionic liquid for any respective application, designing particular ionic liquid for the respective application. Designing non-ionic liquids for many applications, that is a major important task, excluding the earlier limitations as well. And making widely available naturally is important. Finally, I'll stop here and I'll acknowledge to our Director General, Rani sir, M. V. Kulkarni sir and Rani sir for scientific input, always available different research. Dr. Manish sir, Dr. Mari sir also for always available for all lecture series and for scientific input. IT for scientific, for financial support, and all students. Thank you.
Thank you, sir. If anyone have any question, just put in chat box, or you can ask directly. Raise your hand and you ask the question. I think here is no question. So I Amol Kambe, project staff on MIT sponsored project entitled as creation of R&D culture in electronics material among SC, ST and women students in Maharashtra at CIMET Pune. On behalf of project team, I would like to express my sincere thanks to all the faculty members and students for joining the webinar. Also, I would like to express my deep sense of gratitude and thanks to today's guest speaker, Dr. Nagesh Khupse sir. It is very interesting and informative talk. Thanks again. Now I kindly request all the participation. Just open your camera. We take a one photo. All the participation, just open your camera. Okay. So I announce that program is lecture is over. Thank you. Thank you very much.